Good day, everybody. Now, I can remember in the last class, we were talking about equilibrium. This class is going to be a bit lengthy because I had to more of like work on we taking equilibrium to a different level. Now, we all learned about the dynamic equilibrium. We all learned about the facts, about the whole things about KC, KP, and everything. Yeah, we learned about that. Now, today, I'm going to be looking at it in a different dimension. Another dimension is taking it, we are taking the chemical equilibrium now, relating it to acid and base. Now, we've heard about acid and base chemistry. The easiest definition of acid and base, we say acid is a substance when dissolved in water gives what they call hydrozonium ion. Yeah, that is true. That is true. Today, we are going to be taking acid and base to a different level. And I'm going to be trying to explain it and relate it to chemical equilibrium. And I would like every one of us to please follow up because we are trying to do a lot of things here. So now, first of all, we need to relate and know first that acid and base were defined by various scientists. There are like about 3 of them. The first one is Arrhenius, the second one is Bronsted, and the third one is Lewis. But today we'll be looking at the first 2, which is what? Arrhenius and Bronsted base. Now, the first thing we need to know is Arrhenius theory. Let's consider Arrhenius theory. We consider that in Arrhenius theory, Arrhenius defined acid as a substance which dissociates in water to produce hydrogen ions. That was Arrhenius theory. He was able to propose that acid, when dissolved in water, they give hydrogen ions. So for example now, if I dissolve HCl plus H2O, I will get what? H3O plus Cl minus. Now, this is based on Arrhenius. So when we dissolve an acid in water, we get either hydrogen ion or hydrozonium ion. Please, I want you to follow me and get what I'm trying to say here today. Now, if this is for Arrhenius, he also said that a base, what happens when a base dissolves in water? It tells that when a base dissolves in water, it gives what they call hydroxide ion, the OH minus ion, OH minus, OH minus. This definition was based on Arrhenius. It was based on Arrhenius, but there were issues. There were issues. That's why you need to know about these issues. Limitations of Arrhenius. Limitation 1 is that Arrhenius theory can only be applied in aqueous solution. That is the only thing. That means if you want to dissolve an acid and base, you need a solvent that is only water for this theory to work. That is not really, I don't think that is actually a very good thing because we've gone to the modern world whereby we know that there are a lot of solvents, various levels of solvent. So we need to know that that is a very good, that is a limitation to Arrhenius theory. And another one again, OH minus ions, they do not exist in water, but you need to know that the H plus ion and the OH minus ion, they are produced by what? By the acid and base when they dissolve in water, and they are not free in nature. They are not free in nature. So they only exist when the acid and base dissolve in water. When they dissolve in water, that is one thing you need to know. When they dissolve in water, that is when you claim or you say that they are present. The third limitation was the fact that he said that some base do not contain OH minus ion, and that is true. It's not all base that contains OH minus ion. There are some base that base like NH3, for instance. Now, NH3, a very good base, a very, very, very good base. It does not have OH minus ion. It does not give us OH minus ion. So that is one thing we need to know. So Arrhenius base is one that produces OH minus in water. You can see the slide. Yet there are compounds like ammonia, calcium oxide that are bases but contain no OH minus ions in their original formulation. That is one issue there. Let's go down. Let's see what happens. Arrhenius model of acid and base, they are not that they have proved very helpful. Yes, you cannot lie to the fact that they have been helpful in what we are trying to do here about acid and base. But however, we need to know that due to the limitation of Arrhenius theory, we can prove more, we can study more, we can at least go further and research more. And that was where a scientist called J.N. Bronsted and J.M. Lowry. I tell that again. In 1928, J.M. Bronsted and J.M. Lowry, they independently proposed what they call a broader concept of acid and base, a wider concept of it, and they both led to what they call the Bronsted-Lowry acid and the Bronsted-Lowry base. And what does it mean in this acid? What does it mean in this base? It's trying to tell that Bronsted-Lowry acid and Bronsted-Lowry base trying to tell that a boson. I take that again. That Bronsted-Lowry acid, Bronsted-Lowry acid donates proton, but the base, they accept proton. They accept proton. Let's try to get this gist very, very well. They accept proton. You can see that example that I showed there. You can see me showing NH3 plus H2O, giving us, you see, NH3 plus H2O, giving us what? NH4 plus and OH minus ion. So you can see NH3, you can see OH, H2O, NH3 there. What happened to NH3? You had NH3 before, we're now having what they call NH4 plus. That means NH3 as what? Has accepted a proton. It has what? Accepted a proton. We can conclude that in that reaction there, NH3 is a Bronsted-Lowry base. We have OH minus. OH minus, you can see clearly that H2O has donated a proton, and that has caused the formation of OH minus ion. And therefore, you can call that H2O is a what? Is a Bronsted-Lowry acid. You see what is why it is somehow different from arrhenius, different from it. So a Bronsted-Lowry acid donates proton, Bronsted-Lowry base accept what? Proton. Now, based on this, you can see clearly that if you look at the next, you have what we call examples of Bronsted-Lowry acid and base. You can see that diagram. Hydrozonium ion is formed, and we have Cl minus. So you can see that. Let's do what they say. They said HCl gas and H2O. So when dry HCl gas dissolves in water, each HCl molecule donates a proton. So each HCl molecule, they donate a proton to form what they call Cl minus. To a water molecule. So a water molecule now accepts a proton to form what they call hydrozonium ion. And like I've showed you earlier on, H2O, in this case here, in the case of we are using the HCl and H2O, we can see clearly that HCl is the Bronsted-Lowry acid. And that is why you need to pay attention to what? Bronsted-Lowry acid and Bronsted-Lowry base. Now, guys, let's need to know that we have what they call a conjugate acid and a conjugate base. What am I trying to say here today? Now, let's assume the fact that a Bronsted, maybe an acid or a base. Let's assume the fact that an acid or a base. Either accepts or donates proton or any of those reactions that's going on here. We need to know that it's what they call a conjugate acid and a conjugate what? Base. You can see, we take this, go work with this hypothetical reaction. Let's go with hypothetical reaction. So let's say I have an hypothetical reaction. Let's show that on the board. Let's show that on the board so we can get that gist very, very well. Let's show that on the board. So let's try to bring out something so we can easily relate them, because there's a relationship between the acid and base. So let's look at something like that. Let's say I have HA plus B minus. I will form, see that is equilibrium. I will form HB plus A minus. First of all, HA is an acid. B is a base. Guys, what happens? Please follow me. HA, and HA, we donate a proton. HA, we donate a proton. So when HA donates a proton, that means H goes away. We are left with A minus. Like HA donates a proton to have what? A minus. So HA, for it to donate the proton to have A minus, A minus is known as the conjugate base. Now, B minus accept that proton that is being given out by HA to form BH. And this is called the conjugate acid. The conjugate acid. The conjugate acid. Now, this is an hypothetical reaction. This is a very good example. This is a very good example. HCl plus NH3. You have something like this. NH4 plus Cl minus. Aha. What can you see here? What can you see here? You can see NH3. You can see HCl. Now, if I donate a proton to NH3, sorry, if HCl donates a proton here, what happens? Let's see here, what happens. So, HCl donates a proton, the proton goes to NH3. So we can see that HCl is what? Is donating a proton. NH3 is accepting the proton. But what happens afterwards? So when HCl donates a proton, it forms Cl minus. So HCl is an acid. So an acid donates a proton to form what? A conjugate base. A conjugate base. This is a conjugate base. And what? NH3 accepts that proton to form a conjugate acid. It means CE. Conjugate acid. Conjugate acid, conjugate base. Conjugate acid, conjugate base. Now, the next thing is to know. Look at the next point there. And let's see. What is a strong acid? What is a weak acid? We need to understand them. In terms of conjugation, you have conjugate acid, you have conjugate base. Let's do the first point here. They said a weak acid, for example. Acetic acid is a very, very weak acid. It's a weak acid. It produces a strong conjugate base. Acetic acid produces a strong conjugate base. Then what the conjugate base is what? CH3COO minus. And the weaker base, H2O, gives a stronger conjugate acid, H3O plus. What can we conclude from it? We need to know that a weak base will give what they call a strong conjugate acid. A weak acid will give what they call a strong conjugate base. So HCl now is a strong acid. It will give us a weak conjugate base. NH3 is a strong base. We give us a weak conjugate acid. Let's get the chemistry of all this. Let's get the chemistry. Let's get the chemistry of all this. So you see that a weak acid will give a strong conjugate base. A weak base will give a strong conjugate acid. So you can see a question in JAMB, very, very popular questions. You see whereby they are trying to ask you what will be the nature of a conjugate acid or a conjugate base in terms of strength of acid. We need to know that a strong acid base. Next we need to consider here is what? Hydrogen ion concentration. Hydrogen ion concentration. What do I mean by that? What do I mean by that? Hydrogen ion concentration. What do I mean by that? Now, first of all, you need to know pure water is what? Pure water is what? Is neutral. Pure water is neutral. Yeah, it is neutral. Pure water is neutral. And when we say it's neutral, we believe that water ionized very slightly to form what they call hydrogen ion and what? Hydroxyl ions. This is where it looks dicey here. Because, fine, we form H plus ion, we form OH minus ion. But the problem there is that we don't know the amount of the ions present. We don't know it. We don't know it. And that is where we need to understand something here. So if you observe that if you take what they call a conductivity meter to measure the electrical conductivity of water, you observe something. You observe clearly that we derive a constant. The name of that constant is called Kw. That is what the constant is called, what? Kw. And what is Kw? Kw is known as what? Water constant. Water equilibrium constant. We talked about equilibrium already, so we are open to this already. So more like I have more understanding about what you said earlier on. So Kw is called what? Equilibrium constant. So Kw itself is formed from the fact. Now let's bring out something here. It's formed from the fact that when we conduct it, when we first check the conductivity of water, we are able to form a value. But how do we form that value? Let's look up and understand everything. First of all, this is water. You know this is water. We know water itself, that is what? H2O. We dissociate into H plus OH minus. Based on the chemical equilibrium we did, we know that Kw, that is what the equilibrium constant for water, is equals to product over distance H plus, OH minus, over what? H2O. But you know H2O is in liquid form. So it will be 1. Therefore, we have something like this: H plus, OH minus. Now we have this. When we try to check the electrical conductivity of water using a conductivity meter, we're able to deduce that Kw is equals to H plus is equals to OH minus is equals to what? 1 times 10 raised power minus 14. A constant. This is a constant. The constant Kw. From here, we can use our normal mathematics to be able to deduce that H plus OH minus is equals to 10 raised power minus 7. 10 raised power minus 7 molar. That is in terms of what? Concentration. Molar. Now, this is the amount of H plus, this is the amount of OH minus, and that is what hydrogen ion concentration is all about. So you need to know that if this is the concentration based on conductimeter, what if we now want to try to check the amount of hydrogen ion in other acid, in other solution, in various solutions, we can have what they call various values, various concentration of what? Of an acid or a base, or various hydrogen ion concentration or various hydroxide ion concentration. That is where this comes into play. And you can see in the slide clearly there that they said something there that a knowledge of the concentration of hydrogen ions, more particularly hydronium ions, is of the greatest importance in chemistry. That is why we derived, that's why a scale was derived, known as what they call pH scale. Because what if I want to, what one determine, will I be carrying an electrical conductivity meter? Oh, let me tell you, no. We believe that we can make this as a constant, as a standard. Why is it a standard? Because water is neutral. So we can base our standard on this. So based on standard on this, we need to know that chemists now more of like try to determine hydrogen ion concentration using what they call a pH scale. A pH scale. So we are here to understand a pH scale. What is a pH scale? We need to understand that very, very well. What is a pH scale? So you see pH, you see a pH meter, well, having various values. What is going on here? What's going on here? You need to understand it. You need to understand it. So a pH scale can be defined as the negative of the base. Negative of the base 10. Negative of the base 10 logarithm of the H plus concentration. Mathematically, let's look at it mathematically. We observe some things here. That's what, let's observe this thing. Mathematically, we can say that pH is equal to minus log H plus. Mathematically, pH is equal to minus log H plus. Now, you can see the scale there. That is the scale. Let me just draw something. So this scale, center is 7, 0, 14. You can see clearly from here is this is called the acid level, the base. The acid, this is called the acid. So acid pH is less than 7. pH is less than 7. So when we have pH less than 7, we call that an acid. That is acid. That is acidic in nature. pH greater than 7, that is called what? Base. But if the pH is called the 7, that is called the what? The neutral. It's called neutral. Now, that's what they said. The pH of water is 7. It's 7. So all solutions having pH less than 7 are acidic. And those with pH greater than 7 are called what? Basic. I love what is underneath that scale. You can see they say, as shown by the pH scale, pH decreases with the increase of H plus. So as the amount of hydrogen ion increases, pH will decrease. Please let's know this. So the lower the pH, the higher is the hydrogen ion or acidity. The relationship between pH and pOH. We can clearly see that the relationship is telling us pH plus pOH. But today, guys, let's see if we can derive something. We recall that Kw is equal to H plus OH minus equals to 10 raised power minus 14. If I say H plus OH minus is equals to 10 raised power minus 14, then we'll find the what? The logarithm. Logarithm. That is log H plus log OH minus is equals to log 10 raised power minus 14. Log 10 is 1. We can say log H plus log OH minus is equal to 10 is equal to what? Minus 14. So multiply through by 14, we have minus log H plus minus log OH minus equals what? 14. But you need to know that from here you can see that pH equals to minus log H plus POH2. POH is equal to minus log OH minus. OH minus. So this is time for base, this is for acid. So let's quickly do this mathematics. So minus log H plus I can replace it with what? With pH. Minus log OH minus I can replace it with POH. So I can say that pH plus POH is equals to 14. Ladies and gentlemen, please don't joke with this formula. Please don't joke with it. pH plus POH equals to 14. So you can, so therefore, I won't create two. I can show you two formulas that we should not forget. One, this is the second one too. So in case you are working with H plus ions and OH minus ion, you can use this. You are working with pH and POH. We can also use this too. You can also use this too. So now you're not solving an exam question. You see the easier route of getting the answer. You're not passing to the no. Pick something very, very short and get to answer and go to the next question. So let's really see some questions. This is some questions on that part. Example 1. So in questions like this, I advise always write down your data first. Write it down. When you write the data down, it makes life easy for you. Let's read this question. Let's read this question. Let's read this question. Let's read this question. So we can see clearly that the hydrogen ion concentration of a fruit juice is, so we are told that the H plus is equal to 3.3 times 10 raised power minus 2 molar. Minus 2 molar. What is the pH of the juice? They said, what is the pH? They said, now, again, is it acidic or is it basic? Is it acidic? Is it basic? That the hydrogen ion, that means this is what? Hydrogen ion. But we record that pH is equal to what? Minus log H plus. We do this math together. Minus log 3.3 times 10 power minus 2. Doing this math, we will get something like minus 1.48. And this is equal to what? 1.48. Now, guys, you have your pH as 1.48. Is it acidic or is it basic? Let's look at the scale here. We have pH less than 7 is what? Acidic. So it's acidic. This is acidic. So the answer is what? The fruit juice is what? It has a pH of 1.48 and it is what? Acidic. It is acidic. Next question there is that if a solution has a pH of 5.50, has a pH of, so pH of that question is what? 5.50. It's a very good question. Let's pay attention. Calculate its OH minus ion. Calculate its OH minus ion. We know that the relationship between OH minus is to get. Now, guys, we have pH here. We are told to determine the amount of OH minus. But we know that we need what? The POH. See, if we're looking at us there, so we can say that POH is equal to 14 minus pH. So 14 minus 5.50. This gives us 8.50. 8.5. So this is the POH. This is the POH. But we recall that POH is equal to minus log OH minus. OH minus. So we can do the simple math. We can say that OH minus is equals to 10 log. When you let down that, we turn to the anti-log, or 10 raised power minus pH. That is what? 10 raised power minus 8.50. And this can conclude that the answer to that question will be, the answer to that question will be 3.2 times 10 raised power minus 9 molar. 3.2 times 10 raised power minus 9 molar. That is why you see questions like that. So you need to know. So for the so we look at how we can take the questions again. Now for the first one, we learned that the hydrogen ion concentration of a fruit juice is 3.3 times 10 raised power minus 2 molar. And we're now told that what is the pH of the juice? We recall that pH is equal to minus log H plus. What is the H plus ion? 3.3 times 10 raised power minus 2 molar. So if we impute this H plus into this formula here, we can get 1.48. If you have 1.48, we need to know if the pH is this juice, is it acidic or basic? But we can clearly see that the pH is less than 7. If pH is less than 7, we can conclude that this is what? Acidic in nature. And this is a very good question. The next one again, we are not told that the pH is 5.50. Now, if the pH is 5.50, we are told to determine the amount of the OH minus ion. Ladies and gentlemen, we don't know the amount of the OH minus ion, but we can recall that there's a relationship that links us to the OH minus ion. And what is that relationship? The relationship is what? pH plus POH is equals to 14. So POH is equals to 14 minus pH. We are told that the pH is 5.50. So this is what? 14 minus 5.50. And this is what? 8.50. This is the POH. Now we have POH. We can get what? We can get the OH minus ion. We recall that POH is equals to minus log OH minus. Guys, we can do this. Let's make this way the formula here. Let's do that little math. Let's do that little math again. Let's do that little math again. Let's do that little math again. So we have the POH is equals to minus log OH minus. Make the formula. This will have what? Log OH is equals to minus POH. Take any anti-log of both sides, anti-log. So we have OH minus will be equals to 10 raised power minus POH. And that is what? 10 raised power minus 8.5. You put your calculator, we get 3.2 times 10 raised power minus 9 molar. So this is a very good question. Let me see how I can drop one question for everybody to try. This question goes like this. What is a very good question? This one goes like this. What is the pH? What is the pH of a compound with an hydroxyl ion concentration of 2.8 times 10 raised power minus 6 molar. Please all attend this question. So I'll just give everybody 3 minutes for this question. Let's see if we can attempt it. Now, I saw a question whereby you were asked that the jam calculator does not have log. That is a very good question, actually. That is a very good question. That is the reason why most of the times in exams, we are mostly given concentration whereby you can be told that the h plus a yon is 1 times 10 raised power minus 5, for example. That means you're finding the amount of the pH or so. That will be pH is equals to minus log 1 times minus 5. Minus 5 is what? Minus log 10 raised power minus 5. This is like you saying minus 5 equals to log 10. Sorry, log 10. And log 10 is 1. So minus and minus is what? 5. This is the answer of your pH. Most of the times, they are mostly giving values like this. They're mostly giving values like this. So when you are giving values like this, you can easily what? Get the pH or pH. But this is a very good area of exam question. So you need to know that better. Let's try this question together. We're told that we're told that what is the pH of a compound with an hydroxyl ion concentration of 2.8. Now we are giving hydroxyl ion. That means OH minus is equals to times 10 raised by 6 molar. The only thing you can get from OH is POH. So we can say POH is equals to minus log 2.8 times 10 raised by minus 6. So let's do that math. Log 2.8 log 2.8 times 10 raised by minus 6. So that is minus, open bracket, minus 5.55. So this will give us what? A positive value of 5.55. Guys, you can see something from this. You can, from what you're doing here, please don't forget your laws of log reading. Very important. So I have pH, they said you get what? pH. But they call that pH can be said to be 14 minus POH. We can say 14 minus 5.55. So 14 minus 5.55. And consider is what? 8.45. So this is the pH. 8.45. If this is the pH as 8.45, therefore we can conclude that this substance or the compound is basic. Is basic because pH is greater than 7. Greater than 7. So guys, the one way we can use to understand this concept very well is to go back, practice questions like this in our jam pass question. Please, let's do that so we can get this concept very, very well. As you can see now, you probably understood how everything is being done. So go back, practice your jam pass question. So guys, thanks for your time today. I really appreciate. We'll take another topic next class. Do have a nice day.